This is our second video about the properties of logarithms. And in our first video, we just introduced the properties. Now we're going to actually use them. All right, so just as a quick recap, right, these were our three properties, right? If I had log base b of x plus log base b of y, right? In other words, if I'm adding two logarithms that have the same exact base, right, the answer is one logarithm with the same base of the product, x times y. These two multiply. Right, and same thing, if I'm subtracting two logarithms that have the same exact base, right, that's equal to log base, in this case b, of the quotient, right, x divided by y. Right, and then the third property that we talked about was if I have y times log base b of x, that's equal to log base b of x to the y power. Right, so this number, or this, whatever number's here, that we can use that as an exponent. All right, so now I'm going to show you how is this useful. All right, so let's say I've got this long string of logarithms, right? Log base 3 of 6 plus log base 3 of 10 minus log base 3 of 15, right? Well, and what we're going to try to do is we're going to try to simplify this. We're going to try to make this just a single logarithm. We're going to rewrite this as a single logarithm, and we're going to use those properties that we know, right? So let's think about this. Let's add these two logs together. Log base 3 of 6 plus log base 3 of 10. Right? Well, when I add those two together, that's equal to log base 3 of 60. Right? It's not equal to log base 3 of 16. It's equal to log base 3 of 60. And then I need to subtract. So if I have log base 3 of 60 minus log base 3 of 15, right, this is actually equal to log base 3 of 60 divided by 15, right, which is 4. So this is equal to log base 3 of 4. Okay, and so this whole thing, we can just simplify that using our properties, and this whole thing is equal to log base 3 of 4. Let's look at another one. I have log base 6 of 8 plus 2 times log base 6 of 3 minus log base 6 of 2. Right? And one thing I want to mention, I think I mentioned this earlier, but these properties, remember, they only work when everything has the same base, right? So you can only use this when we have the same base. All right, now, the property I want to start with first is, what do I do with this 2? 2 times log base 6 of 3, right? You should always take care of this kind of thing first. Well, remember, this, our last property says that this, we can use it as an exponent. Right? So in other words, I can put this 2 as an exponent on top of the 3. So in other words, this would become log base 6 of 8 plus log base 6 of 3 squared minus log base 6 of 2. Right? And if we simplify that again, this is log base 6 of 8 plus log base 6 of 9. Right? 3 squared is 9 minus log base 6 of 2. Right? And then we can keep on going and keep on simplifying this, right? I can add these two logs, right? Log base 6 of 8 plus log base 6 of 9, that's equal to log base 6 of 72. Now, subtracting log base 6 of 2, well, when I subtract, this is going to be a division, right? So this is equal to log base 6 of 36. 72 divided by 2 is 36. And so this whole complicated thing simplifies to log base 6 of 36. And then wait a minute, I know this logarithm. Log base 6 of 36, that's equal to 2. So this whole logarithm expression here, that's actually equal to 2. All right, I'm going to have you try this now. Okay, so go step by step and try to use the properties of logarithms. And again, your goal is to have a single logarithm at the end. All right, so please pause and try this one on your own. All right, here's how this one would work. So you can check to see if what you did is right. Okay, so first thing I would do is take care of this 2. And remember, that can become an exponent. So this would become log base 7 of 4 squared, which is 16. Right, plus log base 7 of 10 minus log base 7 of 2. Okay, and now if I add these two logarithms, that's going to become log base 7 of 16 times 10 is 160. minus log base 7 of 2. Right? And then if I subtract these two logarithms, that will become log base 7 of 160 divided by 2 is 80. Right? So this whole mess here is actually equal to log base 7 of 80. I want you to try another one. And this time, all these are log base 10. And one hint I want to give you is do what's inside the parentheses first. Okay? All right, so please pause and try this one on your own. All right, now that you've done it, let's check. So if I subtract these logs, log base 10 of 40 minus log base 10 of 5, that's equal to log base 10 of 8. So I have 1/3 times log base 10 of 8 plus log base 10 of 3. Right, and now let's use this 1/3 as an exponent. So this would be log base 10 of 8 to the 1/3 power plus log base 10 of 3. Right, and let's think about this. What's 8 to the 1/3 power? Well, that's the same thing as the cube root of 8, so that's the same thing as 2. So we have log base 10 of 2 plus log base 10 of 3. And if we were to add those two logarithms, that's equal to log base 10 of 6. So our answer is that this whole thing is equal to log base 10 of 6. All right, so far I showed you how you can use these properties to simplify some expressions. Now we're going to do some examples where we go the other way, right? In other words, we've been starting with something like this and changing it to one logarithm, right? But there's actually going to be times when it's useful to go the other way. In other words, we're going to start with something like this, and we're going to make that into two different logs that are being added, right? If we have a logarithm of a division problem, we can change that into a subtraction of two logs, right? And same thing here. If we have a log that has, we're taking the log of something that has an exponent, we can bring this exponent into the front. Okay, so we're kind of going backwards now. All right, so we're going to evaluate these using our properties. Right? So I'm going to do these three, and then you're going to try some. So if I have log base 2 of this quantity, 8 times 16, right? Well, I don't really want to multiply 8 times 16 in my head. But I could use the properties of logarithms to say that this logarithm is equal to log base 2 of 8 plus log base 2 of 16. Right? And now this is so much easier because I know what this is. Log base 2 of 8, that's 3. And then log base 2 of 16, I know what that is. That's 4. So this whole thing is equal to 7. Right? Let's try another one. I have log base 6 of this thing, 36 over 216. And I don't really want to reduce this fraction. I don't want to divide this. So let's use our properties. Right? What do we know about the logarithm of a division? Right? Well, that would be the same thing as log base 6 of 36 minus log base 6 of 216. Right? And again, I know these logarithms. Log base 6 of 36, that's 2. Minus log base 6 of 216, that's 3. So 2 minus 3 is -1. So these are my answers. Okay, and I'm going to do one more. Right here, I've got log base 5 of this whole thing, 125 to the 7th power. Well, I don't really want to figure out what 125 to the 7th power is, and even if I knew what that was, I don't want to have to take the logarithm of that. So let's use our property to make this easier. Right? Well, this exponent, I can bring that to the front. So this is equal to the same thing as 7 times log base 5 of 125. I know what this is. This logarithm is equal to 3. So this is equal to 7 times 3, which is 21. Right? And so hopefully I showed you there that you can use these properties to make complicated looking things a lot easier. All right, I would like you to try these three. So please pause and try to do these three. Okay, and the last one is definitely the hardest, right? But hopefully you'll have success. So pause and try that. Okay, here are the answers real quick. So for number 8, I can rewrite this as log base 3 of 9 plus log base 3 of 81. Right, log base 3 of 9 is 2, log base 3 of 81 is 4, so 2 plus 4 is 6. the second one, I can rewrite this as log base 9 of 81 minus log base 9 of 3. Okay, now log base 9 of 81 is 2. And I'm going to subtract log base 9 of 3. Well, log base 9 of 3 is a half. Right, so 2 minus a half, that's 1.5. Right, or some of you might have written that as 3 over 2. Either way is fine. So either this or this. Or you could even write 1.5 if you want. Okay, and the last one, let's think about this. I've got log base 4 of 16 times 64 to the third power. Well, what I want to do first is I'm going to take this 3 and bring it to the front. Right, so this is equal to 3 times log base 4 of 16 times 64. Okay, now I can also do something else with this. Okay, so let's leave this 3 in front. So 3 times, and then let's break this down, right? What is this? Log base 4 of 16 times 64, that's equal to log base 4 of 16 plus log base 4 of 64. Okay, and I know what these logs are, right? Log base 4 of 16 is 2, so we have 3 times 2 plus log base 4 of 64 is 3. So 3 times 2 plus 3, well 2 plus 3 is 5, so this is just 3 times 5, which is 15. And there we have it. Using our properties of logarithms to make these hard-looking things easier.